Alright, so we're moving on from decimals into fractions, and we're going to have to be able to multiply and divide with fractions, but we're starting with a review of adding and subtracting with fractions, just to make sure everybody's on the same page. So start with a warm-up. Hershey's bars come with 12 pieces. Aaron and Evan each eat part of a Hershey bar and agree to give their leftovers to their little brother Eric. If Aaron has 3 pieces left and Evan has 4 pieces left, what fraction of a Hershey's bar does Eric get altogether? So you've got that a Hershey's bar comes with 12 pieces. So that's the bottom of a fraction. It takes 12 pieces to make a full Hershey's bar. Aaron and Evan each eat a part of a Hershey bar and agree to give their leftovers to their little brother. So if Aaron has 3 pieces left and Evan has 4 pieces left, that's 3 out of 12 and 4 out of 12. And then they give those to the little brother, so together that makes 7 out of 12 pieces. So the little brother gets 7/12 of a Hershey bar. So the objective for this is that we will add and subtract fractions with like denominators by using pictures, number lines, and numeric representations. Now, I give space on all of these to do pictures, a number line, and numbers. But what I tell kids is that after you do a couple of examples with all 3, you can choose 1 or 2 of them that you prefer. You don't have to use all of them. For some kids, one thing is easier than another. A lot of kids have trouble with the number line, so they end up dropping that one off, and that's fine. So the first one, we have 2/5 and 1/5. So I like to go ahead and draw 2/5. I like to make the pieces a little bigger, so I have the grid space, but that doesn't mean that one box has to be 1/5. I can go ahead and use 4 boxes for each piece and work it out that way. So that's 1, 2, 3, 4, 5 total pieces in the shape. So that's fifths. Because remember, the bottom of the fraction tells you the size of the pieces, how many total pieces. It doesn't tell you how many you have, it tells you how many it would take to make a whole. So 2/5 is 2 out of 5. 1, 2. And 3/5, 1/5. I am adding 1/5. So when I put that together, what I get is a total of 3/5. I can also show that on a number line. I start with 0. That's 0. And then I have 1/5, 2/5, 3/5, 4/5. 5/5 makes a whole. So 1 whole is the same as 5/5. So I start at 2/5. See, 1/5, 2/5. And then I add 1/5 plus 1/5. That means I go up 1/5. And I end up on the 3/5 space. So that's the number line. And then if I show that with numbers, it's just 2/5 plus 1/5 equals 3/5. So with fractions, the bottom stays the same because it tells you the size of the piece when you're adding. And then you just add the top. Okay, as long as the bottom is the same, it stays the same, that is. 3/8 and 4/8. I'm not even going to draw a picture for this. It's just 3/8 and 4/8 makes 7/8. I'll start drawing pictures again when we get to some of the more complicated ones, but this is just practice, the same thing as before. And here for these, you're going to have to simplify. 1/6 and 1/6 is 2/6. But we have to simplify. Here's where I'm going to start drawing a picture. And I'm just going to draw 2/6 to help us simplify. So I like to draw, instead of just 6 in a row, I like to say, well, I know I can draw 6 like this. And then I can fill in 2/6 like this. 1, 2, that's 2/6. Now, because of the way I drew this, I can see that I have 1, 2, 3 columns split like this. 1, 2, 3 columns with the 2 boxes in each. And one of those is filled in, 1 out of the 3. So 2/6 is the same as 1/3. We get that by dividing by 2. We put 2 pieces together to make one bigger piece. Divide by 2 and we get 1/3. Now, I don't have to draw it like this. I could also have 6 pieces like this. With 2 filled in. And I can still see that I can put 2 together and divide it into 3 pieces. That's fine too. And even if I had done it like that, but I had filled it in a little differently. Maybe I had gone to the right when I filled in my pieces instead. So it looked like this. Well, I can still split that into, as long as it's the same number of pieces put together to make each new piece. That's 2 pieces put together. That's 2 pieces put together, and then we have these 2 pieces here. So when we split it, we end up with 1 here, another here, and a third over here, each with 2 pieces in them. So you can, it's easier when it's in the columns like this because you can see it really clearly, but this is also another way to do it. So 3/10 and 5/10 is going to make 8/10. 3/10 and 5/10 is going to make 8/10. And I can simplify by dividing by 2, which would be putting 2 pieces together to make 4/5. And I guess I'll draw this one more time just so that we're really clear on it. So that's 10 little boxes, like so. We have 8 of them filled in. And then when we split that up, we get columns. And there's 1, 2, 3, 4 filled in out of a total of 5 columns. 4/5. 5/12 and 3/12 is 8/12. And that is divide by 4 or divide by 2 twice. And you get 8 divided by 4 is 2, and 12 divided by 4 is 3. 2/3. Okay, and 8 and 2 makes 10. 10 out of 15. And then I divide by 5 on the top and the bottom. And I get 10 divided by 5 is 2, and 15 divided by 5 is 3. So when you simplify, you're just dividing by the same number on the top and bottom until you can't anymore, because 2 can be divided by 2 or 1. 3 can be divided by 3 or 1. If I divide by 1, I still get 2/3, so there's no point in even doing it. So this is as low as it gets, as simple as it gets. Moving on to subtraction. If I have 2/5 and I take away 1/5, well, first let's draw some fifths. So, here we go. Fifths. And I have 2 of them. 1, 2. But then I take away 1, so that to get rid of implies erasing. Think. Bam. So what I'm left with is 1/5. So I have 2/5 minus 1/5 is equal to 1/5. So again, the bottom stayed the same, and I subtracted the top numbers, because I had 2 of the pieces and I took away one of them. Now I only have 1 left. So 5/8 minus 2/8 would be 3/8. And 5/6 minus 1/6 would be 4/6. But this one again we can simplify. So 4/6 can be divided by 2. They're both even. So 4 divided by 2 is 2, and 6 divided by 2 is 3, and that's as low as I can go, so it's 2/3. Now this one was supposed to be subtraction, but since when I subtract I get 5/9, which I can't simplify anyway, might as well do the addition because we actually get something interesting. We get 7 and 2 is 9, and 9 out of 9 is a whole, because if I have 9 spaces and I fill all 9 of them in, then the whole thing is filled in. So I get 1. Now we start using mixed numbers, so it gets a little bit interesting, because what we get is 3/5 and 4/5 is equal to 7/5. But I need to be able to write that as a mixed number. So if I have fifths, 1, 2, 3, 4, 5, and I fill in 3 of them, that's 3/5. And then I want to get, I'm adding 4/5, so I'm adding 1, 2, oh, ran out of room. Well, if I add more to this, then I won't have fifths anymore. I'd have sixths and then sevenths and then eighths and so on. So what I'm doing is I have to add a whole nother shape. So like if this is a candy bar, and it takes 5 pieces to make a whole candy bar. If I have 5 pieces, I have a whole candy bar. If I have more than 5 pieces, I have more than 1 candy bar. So that's 1, 2, 3, 4/5. So what I end up with is 1 whole candy bar and then 2/5 of a candy bar. So that means that 7/5 is the same as 1 whole and 2/5. So what we can also represent this as is 7/5 is equal to 5/5 and 2/5. And 5/5 is the same as 1, so 1 and 2/5. So you can kind of split it up that way, see how many fifths you have, or how many times you have 5/5, which is a whole. So let's look at something similar here. I'm not going to use pictures, I'm just going to use that space for this. So 5/8 and 5/8 is 10/8. So if I have 10/8, well, I have 8 out of 8 would be a whole. But if I take away 8 out of 8, I still have 2/8 left. So that's 10/8, or 1 and 2/8. And then that one I can actually simplify, because 2/8 I can divide by 2 on the top and the bottom, and I get 1 and 1/4. So as a picture, that would look like 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Like this, and then I need another one. Because I know it's going to be more than 1 whole. And so I have 1, 2, 3, 4, 5, and I add 1, 2, 3, 4, 5 more, and I end up with 1 whole and 2/8, but 2/8 can be split up into 4 sections, and one of the 4 is filled in, 1 out of 4. So that's why 2/8 is the same as 1/4. Okay. Same idea here. 5 and 7 makes 12, so that's 12/9. 12/9 can be split up into 9 out of 9, and that means 12 minus 9 is 3 left over, and 3 out of 9. So that's 1 whole and 3/9. But that can be divided by 3, so that gives me 1 and 1/3. And I know I'm just using this represent with picture space, but I just want the room to be able to really see it. I could do it with pictures as well. That would be 9, like this, and 9, like this. And I have 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5, 6, 7. So that's 1 whole, or 9 out of 9, and 3 out of 9, or 1 out of 3. And 11/12 and 5/12 is 16/12. Okay, now 16/12. Why don't I go ahead and simplify this one first to just mix it up some. 16/12 divided by 4. 16 divided by 4 is 4. 12 divided by 4 is 3, so I get 4/3. Now 3 out of 3 would be 1. So if I take 3 out of 3 away from this, then what I end up with is 1/3 left over. So this is the same as 1 and 1/3. And if I'd done that the other way, if I'd done it as, well, 16/12 is the same as 12 out of 12 plus 4 out of 12, which is the same as 1 and 4/12. And then I can divide by 4, and I get 1/3, 1 and 1/3. So I get the same thing either way, whether I simplify first and then turn it into a mixed number, or turn it into a mixed number and then simplify. Okay, now subtraction. 1 4/5 minus 3/5 is easy. I have, let's see, fifths, and I have 2, 3, 4. So I have 1 whole thing of fifths, so that's 5 out of 5, and then I have another 4/5. And what I do is I take away 3/5. Let's make this small. So that's 1, 2, 3. So that leaves 1 and 1/5. Whoa, let's make that black again. 1 and 1/5. Easy peasy. 1 5/8 minus 1/8 is 1 and 4/8, which is the same as, oops, divide by the same on the top and the bottom, 1 and 1/2. Here's where it gets complicated. If I have 1 and 5/9 minus 7/9, well, I can't take 7/9 away from 5/9, so I'm going to have to borrow from the 1. If I draw that as a picture, I have 1 whole thing of ninths. So that's 9/9. And then I have 5/9. So I have 1 whole, and then I have 5/9. 1, 2, 3, 4, 5. Take away 7. 1, 2, 3, 4, 5, 6, 7. So what I end up with is 1, 2, 3, 4, 5, 6, 7/9. I can also show that with numbers as 1 and 5/9 is equal to 9/9 and 5/9 is equal to 14/9 minus 7/9 is equal to 7/9. So I just split it into, instead of 1 and 5/9, I put it, the 1 as ninths, 9/9, and 5/9, which is 14/9, minus 7/9 is 7/9. So this one would be 12/12, and 1/12 is 13/12. minus 5/12 is equal to 8/12 divided by 4 on the top and the bottom gives me 8 divided by 4 is 2, and 12 divided by 4 is 3/2. Then the kids have an exit card. It's worth 20 points, but it's scaled, like it's actually 12 points on here, and then scaled up to 20. So it's 2 points for each question, and 2 of them need to be simplified, and 1 of them needs to be converted from an improper fraction to a mixed number. And this one is just like the subtraction problems we just did, where you can't take 3/5 away from 1/5, so you have to borrow from the whole. And then the homework, of course, is the last page of the packet.